Hello, everyone. Good morning, good evening, and to all are joining us globally. Yes, I am Parth Varu, the event program manager for Microsoft Reactor Bengaluru, and from India. Yes, today we are going to deep dive into Azure Load Testing and Azure Kubernetes Services by Anthony Shaw. But before we start today's event, let's go through our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in a way we all engage. Yes, we do encourage you all to participate. Please drop all your questions in the comment section, and we have our moderator Nikita to answer all the questions. And in between, if the time permits, we have Anthony as well to answer all your questions. Yes, so now let's not delay anymore. I like to bring in Anthony, who's speaker for today's session. Hey, hi Anthony, how are you?
Yeah, I'm good, thanks. How are you?
Sorry to disturb you a bit, folks. Anthony is joining us from Sydney, and it's like 10 p.m. there, I guess now.
Yeah, it's a bit later in the evening, but that's normal. Working in Australia, we often join people at strange times of the day, so it's fine.
Okay, Anthony, I would like your permission for your quick intro to our audience there.
Yeah, sure. So I'm a principal developer advocate at Microsoft, and I focus on Python. So most of my work is in Python development on Azure, but I do a lot of work also on other services around Azure, other platforms. So you'll see me demoing and showcasing different capabilities within Azure. But my main focus is Python. I've written a book on Python, a fellow of the Python Software Foundation as well. So yeah, a lot of my focus has historically been on Python, but I do other things as well.
Oh, that's great. That's great, Anthony. Good to know you and good to have you on at another episode of Azure Load Testing. Yes, Anthony, the floor is all yours, and I will be at the backstage. Please do let me know if you need anything.
Okay, brilliant. Thank you. Um, so today we're going to talk about Azure Kubernetes Service and Azure Load Testing. So to recap, I guess if you've been with us for for the last few episodes, so the last couple in particular, we're going to kind of build on what was shown in the last couple of episodes. So in with Nick Trough, he talked about integrating Azure Load Testing with CI/CD and JMeter-based tests. So this is how you use Azure Load Testing and some automation to automatically test your application. Or then we also had optimizing performance with Azure Load Testing, which is more so like an overview of what Azure Load Testing is, how it works, and how to scale it out. So if you've gone through the last couple of episodes of this Reactor series, then hopefully you've got a good picture as to what Azure Load Testing is, how you would use it to run a load test on an application, and then how you could use something like CI/CD to automate the process of actually running the load test. So what I want to do today is actually build on that and take it a bit further and actually talk about how the platform, if the platform is Kubernetes, how that works with load testing. Because when you run a load test, often the thing that you're testing changes often. And it's not quite as simple as having one application that you're testing. Often you're testing lots of different applications, or the application infrastructure is a bit more complicated. So that's kind of what we're going to talk about today. I've got a demo app and a repository with all the code of everything that I'm going to show you. So the links will be available for that. It's all on GitHub. There's also video recordings of that demo in particular. So if there's anything maybe I didn't go into enough detail on today, or you missed, there'll be links as well at the end of the session. If you do have questions, please ask them as we go through. I'll try and glance to my other screen to see questions and hopefully answer them. So what we're going to do first is talk about Azure Kubernetes Service and what it is. I'm going to talk through the architecture of this demo application, then we're going to talk about the challenge of load testing it. And how do we address that? How do we automate it? And how can you use these two things together to actually work out the right architecture for this app? So Azure Kubernetes Service is quite a mouthful. So often we will just refer to it as AKS, because saying Azure Kubernetes Service over and over again makes you need a glass of water because it's quite a lot of syllables. But what is AKS and why might you need it? So AKS is basically a service on top of Kubernetes. So Microsoft runs Kubernetes for you in Azure and automates all of the deployment of the infrastructure, all of the monitoring, all of the patching. And the way that you interface with Kubernetes is just via the API, but all of the other components are basically done for you. Often when people are running Kubernetes in production, Kubernetes, the technology on its own is often not enough. If you're not familiar with what Kubernetes is, it's a container orchestration platform. So if you're familiar with running a single container, maybe using something like Docker, if you've got an application that has multiple containers, like a microservice architecture, and you need to orchestrate the multiple containers running in different environments, maybe you have multiple applications. Essentially, Kubernetes becomes almost like a hypervisor. It's the thing that is running all of these containers and all of these environments. There's a lot of abstractions with Kubernetes, and there's also a lot of management containers that you have to deploy and run. So running Kubernetes like manually, actually spinning it up and running it and operating it is a huge amount of work. So often Kubernetes is used in larger environments because there are so many components to get up and running before you would use it. Azure Kubernetes Service does make that easier because we actually have done most of that for you. So we've done the infrastructure stuff for you. We'll spin up all the servers. We'll patch them for you. We'll patch all the components. We've got automation in there. We've got all the monitoring all fully integrated, and all the networking stuff as well. So basically all of that is already done. We're offering it as a managed service. And then all you need to worry about is how you package your containers, how you describe your, in the manifest, how you describe your application, and then you just need to ship it onto the service and it will run that in the cloud for you. So really what you're looking at when you're running Kubernetes generally, or when you're running it on Azure, is that you're actually trying to make your containerized deployments a lot easier to manage, because you're thinking about, okay, I've got this application which is comprised of these containers with these versions, and I want to ship it up into the cloud and be able to run that really quickly. So Kubernetes offers you a way of doing that. But we basically have the foundation, which is we've got all the security built in, all the automation, all the monitoring, and all the patching built in as well. So here's some of the components that you would get in managed Kubernetes on Azure, which is in AKS. So like I mentioned, we'd run all the container apps for you. You've got debugging capabilities, CI/CD, which is something we covered specifically for load testing in the last session. We host the clusters. The clusters are the actual physical servers. So often when you think about containers, you don't have to think about physical servers, but they have to actually run somewhere. So what we do is we spin up the clusters for you. So you basically nominate how much compute you actually need to run your container environments and how flexible you want that to be. And then we can spin up however many virtual machines in the background that you need. And then, like I mentioned before, we patch that environment for you. So we patch Kubernetes as well as all the management infrastructure and run all the security updates as well. And you get auto scaling with that. And you also get monitoring and logging all in the portal. I'll show you this stuff as well. This is I'll show you it up and running. So once you've got that done, let me skip ahead. You can run microservice type applications. And you can also use something like Azure Monitor to monitor those specific microservices. So one thing that you often get with microservices, the idea is that by breaking an application up into smaller pieces, you get better reliability because you don't have single points of failure. Microservices are designed to basically be horizontally scalable and also be redundant, so resilient. Sorry. So with microservices or a microservice architecture, that's one of your goals, is to have that scaling capability. Now, one of the challenges that you get when you look at scaling is that it's not always obvious what is the minimum you need for your scaled application. So what we find is that customers can often over provision or basically over architect an application, and they end up with a lot of resources that are sitting there idle. I don't know if anyone remembers the days before virtual machines, but one of the big selling points of virtual machines was that before we had virtual machines, most physical servers were sitting there with their CPUs mostly idle during the day. And the whole idea with consolidating virtual machines together is that we can actually get better utilizations of the infrastructure. Now, with microservices, because people often have multiple layers to their application and multiple tiers, then you've got to answer lots of questions like how much CPU does each service need? How much RAM does it need? How many replicas should I have? So how many instances of that layer should I deploy? These can often be guesses based on intuition. And what we actually see is that customers often overestimate how much infrastructure they need. And then when the application is actually running, most of their resources are sitting idly. So one thing we're basically trying to tackle, and I'll show you how to do this, is that if you run a load test on your architecture in Azure Kubernetes Service, you can look at, have we over provisioned our CPU and memory? Do we have too many instances running? Can we bring that down so we can actually reduce our costs a bit? So that's one of the things that we're gonna show you. So when you're running in a containerized environment, you essentially have your code, so your application itself, which would live in source control somewhere. So the demo that I'm going to show is all in GitHub, but that can be in any other source repository. The automation that I'm going to use is GitHub Actions. This all works with Azure pipelines as well if you're using Azure DevOps, or if you want to run this with scripts in a different tool like Jenkins, for example, there's a CLI version of all the stuff as well. The steps are basically that you've got your code and your application, you containerize that application, and then you ship it up to something called Azure Container Registry. So Azure Container Registry is basically a private container registry for your Azure environment, and it keeps all the versions of those containers that you've built, and then you can pick one of those versions, and then you can say that's the one I want to run, and then you would deploy that into Kubernetes. So that's what we're going to walk through today. That's a scenario we're going to walk through, and we're going to show you how we then use that with load testing. So to get started with Azure Kubernetes Service, you can either do it through the portal, so you can go through the portal and configure AKS in the portal. You can use the AZ command line tool, or you can use something like Bicep or ARM templates to automate the provisioning of this environment for you. The AKS setup that I'm going to demo, I've included the Bicep and all of the instructions for the commands you need to run to stand it up, because there's a couple of things which are quite specific to this demo, but yeah, this should all be fully automatable as well. So I'm going to skip ahead. Once you've got AKS up and running, the tool that you would use, so if you've already used Kubernetes, you're probably used to using kubectl, or however you want to pronounce it, the command line tool for interacting with Kubernetes, whether that is scaling up or down deployments, running deployments, or managing the the nodes, the node pools. So if you're used to using kube control for talking to a Kubernetes environment, in AKS it's exactly the same. So what you do with AKS is you basically do AZ AKS login, and then it logs you in to AKS, and then you can just use kube control locally to interact with your AKS environment, just as you would with any other Kubernetes environment. So the goal is that basically you can use the same tools, you can use the same applications and stuff like that that you would normally use to work with Kubernetes. But with AKS, we're managing the infrastructure for you. We manage the security and the patching and all of that stuff as well. So if you're already using AKS, let me go ahead. There's a lot of stuff here. So if you're already using AKS, sorry, not AKS. So once you've got Kubernetes up and running, there's a couple of things to keep in mind. Let me skip ahead. So one component I wanted to talk about was the Azure Container Registry, so ACR. So there's basically three parts to this demo. The first one is we've got AKS and an AKS environment. The second thing is we've got an Azure Container Registry, which is basically keeping the built containers. So a copy of the containers that we've built with the application. And then the third thing is we've got a load test. So the load test basically is the one we've designed based on what you'd learned in previous sessions using JMeter. And this is a really basic load test because I've built the most simple app I could think of. It's just a website with a button and you click the button, just to keep it super simple so it's obvious what we're testing. In reality, your application is probably much more complicated, but at least you've kind of got a foundation. You can see this application and build on top of it. So Azure Container Registry is, or some sort of container registry is a requirement for AKS because you need to build the containers first and store them somewhere in order to deploy them into Kubernetes. So you can use other container registries. Azure Container Registry is, the integration is built in with AKS, and it's also got a bunch of advanced features that you won't necessarily get in other places like a Docker private registry. For example, we do a whole bunch of security analysis tools in the containers, so you can run scans on the containers and you can link them together as well. So we've got replication between different geographies. So if you're building it once, but you want to deploy it to multiple regions, we can do that replication as well for you. So I'm going to go ahead to show what the application architecture looks like. So like I mentioned before, this is a really simple app. Maybe this architecture doesn't look that simple, but I promise you it's as simple as I could make it. Kubernetes is always complicated. That's one of the great things about working with Kubernetes. So we've basically got a front end and a back end. Our front end is a simple Python web app where you can click to vote for your favorite animal, whether that is cats or dogs. And then the back end is a Redis cache, basically that stores the number of votes that people have cast. So there's only two layers in the application. There's the front end and the back end. And now we've also got different environments. So we've got a staging environment and a production environment. So in what is called a node pool, and I'll show you the node pool in a second. I'll switch to the portal. In the node pool, we've basically got a staging environment and a production environment. Staging has one front end and one back end, so it doesn't scale horizontally. The production environment has a load balancer for the front end, and then you can have as many front end containers as you want. And then it has a vertical scaling for the back end. So the back end it is not using scale out on Redis, but we can increase the amount of CPU or RAM that we put to the Redis environment. So what we really wanted to test here was before we deploy into production, we think we know how many users we're going to get, how many instances of the containers should we deploy, and how much CPU and RAM should we give them. So this is going to be one of our questions as we go through this demo, which is once we've designed a load test for it, can we actually look at whether we've over-provisioned or over-architected our application? Because that's a really important question. Because when you're looking at all these layers, if you say, okay, we want 3 front-end servers and each one has half a CPU and half a gig of RAM, is that a good number if we only have 100 users? So that's an answer we can get to with Azure Load Testing. Okay, cool. So let me jump to the portal and then we can have a look through this. So this is my resource group. This is my AKS environment. In AKS, one of the most important things, well, there's 2 kind of important things to look at. One is a namespace. Namespace is basically a way of grouping some of the containers or the environments that are running within Kubernetes. There's a lot of, once you deploy AKS, the monitoring tools and all of the management containers that come with AKS are already running. So you'll see a lot of things like kube system or gatekeeper. These are basically like the system processes that are running in the background. So you would normally define then an additional namespace so that you can manage, I guess, other containers and other applications that you've deployed. So we've got a default workspace, which is where our actual apps go and where our workloads are being deployed to. So namespace applies basically across all node pools, and it's a label that we can basically apply to multiple different workloads. The next thing you need to define is the node pool. Node pool is basically a pool of nodes, obviously, but a node pool is actually like the virtual machines that are running the containers. So a node is an instance of a container running in a node pool. And in order to run containers in Kubernetes, you need to have a node pool configured. I've created one. And it's a very basic node pool, but it does have automatic scaling configured. So the minimum number of nodes that we've set up is 2. So we've basically got 2 virtual machines that are running at the moment, and we've said that we can scale up to 10 virtual machines. In here, you also configure for the node pool what virtual machine size you want to run. So 2 vCPUs and 7 gig of memory. So this is one of the smaller virtual machine sizes. They do go up to much, much larger. You'll also get information about the CPU usage, the memory usage, and how much memory has been allocated in this report. But there is another page you can get that detail as well. So what the auto scaling will do is it will basically look and see if you've asked for more containers to be run in that node pool than there is memory available. If it needs more memory, it will deploy more nodes automatically. Now, there's a cost associated with that. So this is why it's important to remember with any auto scaling, not specifically for Kubernetes, but just any auto scaling environment. The more resources you ask for and the more you scale out, the more costs you will have. So the auto scaling works on the allocated size of the containers. So if you provision 10 containers and each one you've asked for a gig of RAM, it's going to ask for 10 gigs of RAM, regardless of whether or not the containers actually need a gig of RAM. So this is where load testing comes in, because what we find is that people can create this They set up auto scaling, and then most of their containers actually have more memory or more CPU than they really need, and their node pools will scale out. And then most of their CPU resources or RAM resources will actually be idle in production. Now, what you can do with load testing is you can try and right size that configuration. So we've got our node pool set up. We've got 2 nodes at the moment, but that will scale automatically if we need it. And then we've got the services that are deployed into this environment. The place where I've put mine is this demo is all in GitHub. This is my version of it, but the template repository is here. So if you want to clone this demo and have a look through any of the samples, all of the instructions are in here. It's all on GitHub for you to look through. In my demo, I'm basically deploying my version of the application, and I'm running it and deploying it into this AKS environment. So the next thing I've got to show you is the container registry. So in GitHub, I've got a workflow configured, which is to provision and deploy. So for example, I think this morning, I made a couple of changes to the version of Redis that we were running in this application. So I've defined a workflow that will build the app. So it will log into the container registry. It will build the actual image. So it does the Docker build of the image of the application. It does this in GitHub Actions. And then it's going to push that image up. And then the next thing we do in our process for provision and deploy is we run a load test. So what I wanted to do with my build flow is that every time I make a change to the app, so every time I make a change to the main branch in my application, I'm going to compile that. I'm going to deploy it to staging, and then I'm going to run a load test on the staging environment. This is very similar to what you saw in the previous session with the CI/CD discussion, but I'm doing it in AKS. That's the difference. So when I showed you the architecture before, where we've got staging and there's one front end and one back end, and then we've got production where you've got scaled out front ends and then just a single back end. What this build flow is doing is it's building the application, building the container. It's uploading it to Azure Container Registry, and then it's telling AKS to use the new version of the app, but only in staging. And then once it's successfully updated the staging environment, it's going to run a load test. So let me show you the actual GitHub action for this. So this is the YAML for what we were discussing. First thing we did is we log into the container registry. You need to have a secret for the login and the token, which is like a login key. And then the next thing you want to do is you want to tag the image. So when you build a Docker image and then you push it to a container registry, you need to give it a label so that you know what that is. In Azure Container Registry, when you go in the portal, you'll see on the left, if you go to repositories, it will have a list of all of the repositories that are pushing container images up. And then it will have a list of tags. Often there's one called latest, which refers to the latest tag that's been built. Or you've got a tag like this, which is a very long number, but it's also got other metadata in it. So anything else that you put in here will be attached to this information. So you can refer to it. The logical thing to do is to add a tag that refers to the Git SHA. So if you ever noticed if you type in Git Log, for example, you'll see this long number here. That's basically the unique identifier for that commit in Git. And that's called the Git SHA. So what I've done with this automation flow is basically say, build the code or check out the code and build it, and then add a tag that represents the commit hash of the code that I just compiled. So that I know when I check out that version in the container repository that it refers to this version of the code. Otherwise, it would just be complete chaos, because you wouldn't know if you just use date and time, for example, and you've got two commits that happen at the same time, you wouldn't know which one referred to which version of the code. You can do this with tags as well. So if you're using if you use tags in GitHub, you can add the tags as well. You can also add a branch. So I'm just using the repository and the SHA. You can also put in github.branch and it will use the branch name. But I'm only ever compiling from the master branch and deploying from the master branch. So those are the two tags that I decided. You can customize that as you need. So once that step has done, it says this Docker image is successfully building. Now the next thing we want to do is we want to run a load test. So I've added the latest tag to the code that I just deployed, and then I've set up my environment so that my staging app. This is my Kubernetes manifest. So if you ever work with Kubernetes, you define these YAML files that has a specification that describes the different parts of your application and what they should be running. So I've got the backend container, which is the Redis cache, and then I've got the front end component as well. So the front end component says it runs the front end image, which I defined in my other YAML file. Sorry, when you work with Kubernetes, there's a lot of YAML files. It does get confusing, but hopefully I can go through this step by step and we'll make sense of it. So step one was to build the image, upload it to Azure Container Registry. Step two is we want to run a load test. So what we do with CI/CD is we need to make sure that the staging environment is running that new image. So step one will be to log into AKS from GitHub Actions, which we can do using this command, az AKS get credentials, and then which AKS do we want to log into. You need to have stored a secret key in your GitHub secrets for that to work. There is an equivalent for Azure pipelines as well. The next thing we're going to do is we're going to replace where I said front end image. We're going to replace that with this. Basically, this is the ID of the container that we just compiled. So that's the one I used up here. So that refers to the version of the container that we just built. And I want to run kube control apply, which basically means make sure that that manifest is correct. And what that will do is it will apply the manifest that I just looked at, which is that one, but replace the word front end image with the one that is in here. So it's basically going to say deploy that version of the application into staging as the front end. And then the next thing we do is we run a load test. So you can initiate Azure Load Tests from GitHub Actions and from Azure Pipelines. Now, in practice, there's a couple of things that you want to remember. If you're doing them automatically and you have a large application, often you can have a lot of commits that can happen in a short space of time, or you're running multiple branches and people are committing into different branches. So what you can do with the Azure Load Testing action is you can specify the name of the run, and you can also put in a description field that has some additional messages or some additional information. So what I like to do when I'm automating my load tests is the run name. I like to use the short version of that SHA, the commit hash. So that will be like this number here, but not the whole thing, just the first, I think it's the first 8 characters. And then for the run description, I like to use the commit message. So when I had that commit that I was showing you there, update version for production app, when I go into Azure Load Testing and I look at my staging test runs, I can see there my description is the commit message. So I recognize that commit. And the number here says GitHub action, and then the first part of the SHA. So I recognize that load test run is related to that particular commit. And that's really what you want to get to, is that you recognize which load test refers to which version of the code. Otherwise, it can get very confusing very, very quickly. The other thing we do with our load test is we set the host environment variable. Now, I think in the third session, you saw how when you initiate a run in Azure Load Testing, it will ask you, not that one, it will ask you if you want to set any environment variables. Now, if you've created a load test in JMeter, actually, I've got JMeter open, so I'll show you. This is my load test that I'm doing for staging. Now, the address, the HTTP address of the application actually changes because the staging environment and the production environment are different URLs. I might also have different versions of it running, so I don't want to have to create multiple tests just to change the address that I want to test. So what you want to do with your load test is to basically get make it a variable. So to set in JMeter, when you're running HTTP requests, to basically make the first part of the URL, the host name, to make that a variable. So that's what I do in my JMeter tests. You have to use this funky syntax, but it basically says get the environment variable called host, and then set that as the default server name, and then any HTTP requests in this thread group after that. So this one, for example, just goes to post / we'll always use that host as the target. So that's how my load test works. And then what you do in your configuration is in GitHub Actions, you can basically override then what the host is. So you can either set that manually to be the host if you know what the host is, or in Kubernetes, you can actually you can run a command called kubectl get service, and then you can say what the name of the service is, and it will tell you what the host name is, the IP address or the DNS name of that part. So that's what I'm doing in the script, is basically saying, okay, now that you've deployed this service called front-end staging, can you tell me what the host name is so that I can actually test it? So it's using that as the input into the load test. So what I get as a result of that is that when I look at my my load tests, I can run comparisons of the different versions of the code that have been deployed. So the last change I made was to update the version. That should be Redis, not Redis. So this graph, the purple graph, I updated Redis to be the newest version of Redis. And when I look at the graph, I can see actually the response time has dropped quite significantly for that version. So it's improved quite a lot actually, which is good. So that's a helpful thing to keep in mind. This application is also set up so that if you in the test configuration, if the average response time is longer than 500 milliseconds for the test, or if there's more than 20% errors, it will fail. What that means in GitHub is that this middle part will fail, and then it won't release that to production. So basically what we've created in this CI/CD flow is a way of deploying it to a staging environment, running a test, running a load test, seeing if it meets that performance criteria. And if it does, then we ship it to production. If it doesn't, we cancel it completely. So it will basically stop that. If there's a performance regression, we stop that from being deployed into production. So the next thing I wanted to show you is how we can build on this a bit further. So far, all we've done is we've committed the code. We've built a container using Docker build. We've uploaded it to Azure Container Registry using GitHub Actions. We've given it a tag or a label to say this is the version of code that is in this container. And then we've deployed it to staging. We've run a load test on it. And then once we've got that load test run, we see if it meets our performance criteria. If it does, then we upgrade it to production. If it doesn't, we reject it completely. That doesn't really answer our initial question of when we're designing these Kubernetes manifests. So this is the production one. I've got to answer, as a developer, I've got to answer a few questions here. So I've got things like what CPU limit should I put in? What memory limit should I put in? For the front end, how many replicas should I have? So should I have 3 containers running the front end, 5 containers, 10 containers? And what is the right number? So we've designed a load test. This is a super simple load test. It just sends a HTTP post request to the page with the form data that we need. But in reality, you would generate load that's a bit more complicated. But we want to answer the question, what is the right amount of RAM? What is the right amount of CPU? And how many front ends should we have in our load balancer? So the last thing I wanted to demo to you is using GitHub Actions and all the tools that I've shown you so far, and introducing something which is available in GitHub Actions. It's a really, really useful feature in GitHub Actions, and that's this feature called a matrix. What you can do with a GitHub workflow is you can say, run all of these steps multiple times. Oops, get rid of that. But for each combination of input variables. So I'm not sure if we need 3 front ends or 5. I'm not sure if each one should have 250 M of CPU or 500 M. And I'm not sure if we need 256 meg of RAM or 512 meg of RAM. Like, it could be that 5 replicas with 500 M of CPU and 512 meg of RAM is the right size. It could be that that's overkill. But basically, there's different combinations, and we want to test each of those. If you wanted to test 10 front ends, you could just add it to this list. I've set this particular workflow to run manually because it does take about an hour to run. Each load test, you want to run ideally a load test for multiple minutes for the app to be stable. And because we're running so many different combinations, just the amount of time it takes to run each of those different combinations adds up to a lot. GitHub Actions has this trigger called a workflow dispatch. You might not have come across it before, because often when you're working with GitHub Actions, you would just look at pushes to a particular branch and then running it automatically. If you just say on workflow dispatch, what you get is in the GitHub Actions portal, you'll get a workflow like this, but you trigger it manually. So what we did with this one is we said, okay, let's have a manual workflow that we can run as a one-off, and it will basically run multiple load tests, but with different configurations of the front end. What that looks like is when it runs the this flow in GitHub Actions, it's going to run a load test with 3 front ends, 250 M of CPU, 256 meg of RAM, and then every combination thereon. So it's basically going to change the production environment each time to match that specification and then run the same load test. Now, where that comes in useful is that we can go back into our portal in Azure Load Testing, and we can look at the AKS configuration test run, and I can see all of those test runs in here. So if I want to do a comparison to see, okay, what is the difference in app performance with 3 front ends versus 5, but with more CPU and more memory. So like, let's have a look at those different combinations. I can tick those 3 and then I can run compare. What you'll see in the portal is the performance of the application in that environment. This is useful because I can see, okay, what's the response time with the different configurations? What requests per second am I getting? Unsurprisingly, the more front ends you have and the more CPU and the more memory you have, the faster the application runs. But you might actually make a decision and say, you know what, the line in the middle, the pink line, is actually fast enough. So we probably don't need all of the extra CPU and all of the extra memory. Now, the other thing you can do is when you're looking at the tests in here, in the configuration option, you go to configure and then go to app components. This is basically the integration that we have between Azure Load Testing and AKS. So what you want to do next is you want to find your AKS environment and make sure that is ticked, and then do apply. Once that's done, you go back into, let's wait for that to, that's done. Once that's done, you go back into the configure button and click on metrics. And then there's 3 important metrics you want to add. They're all related to the managed cluster. So one is the allocatable CPU cores. The next one is allocatable memory. And then the third one is the pod status ready. So basically how many pods are running. Those are the 3 basic metrics. But if you click on AKS, you'll actually get a lot more information that you can put in as well. For example, if you wanted to look at the nodes in the node pool and then how much CPU is being used on average of the nodes in the node pool, you can add that as a metric. Or if you wanted to look at memory in the node pool as well, you can pull that in as well. So you can add all of these additional metrics that are running in the server-side environment. And then once you've done that, then if you click on any of those tests and then scroll down, you'll see, is it showing up? When you configure it, it applies for the next test runs, not the existing ones. But you'll see all of those metrics. So you'll see how many CPUs have been allocated, how much memory was available whilst that was running. And then if you want to go and add in what we had for CPU percentage, then we can pull that in as well, and we can see how the CPU percentage of the nodes was impacted during the tests. So that's really helpful because we can see, is this actually, pushing the infrastructure, and do we need to consider adding additional nodes or additional environments. Yeah, that's everything I wanted to demo. So we do have time for questions as well. If anyone has any questions in the chat, or if Nikita, if you had any questions as well.
I think we have one question like, what languages are you using for this?
For the code for the application.
Yep, should be.
This demo application is a Python application, but everything I've shown you is not specific to Python. It's just generic. The only thing that would need to remain the same is the use of JMeter to design the test. The code itself for this app is Python, but you could, if it's an application written in another language, everything that you've seen would apply as well. Yeah, and if you want to look at the sample or see some more detail, as well as links to all the documentation for everything you've seen, then it will be in the Azure samples and the AKS load testing repository.
I think, yeah, we good. You can continue. Yep. That was the question, and rest there were questions. Yeah, there is one more question, I guess. Here, bicep AML Python, as you mentioned for the question. Yeah, he's like helping us out. Yeah, right now. Fine, cool. So you can go ahead. Yep, Anthony.
Okay. There's a question about the free tier of Azure. That is a good question. I don't think there is a. Okay, so with Azure free tier, the place that I recommend, there's a couple of places I recommend you look at when assessing. Each service has a different free tier or a different free amount. If you go to azure.com/free, this is a good place to start. It gives you a good breakdown of some services have a free tier, some of them have a free allocation. Or some of them are just free generally. So this is a good site. So it's easy to remember. It's azure.com/free. And then you can see in here which services have got free components. It also tells you how you could, if you do sign up, and you can get the credit. I don't know if Azure Kubernetes Service has a free tier though, because it's used for. Oh no, it does. It's got something. I've never looked into that in detail. There's a link here for AKS, a free part of AKS. Azure Load Testing, yeah, we talked about in the last one. But yeah, if you are interested in this, then I recommend starting here. The other thing you can do is use the pricing calculator. Pricing calculator, you can basically say, here are things that I want to deploy in Azure. For example, I want a container registry, I want a Azure Kubernetes service, and you can go and put in all the specifications, all the details about where you're going to put it, how many containers you think you're going to run, what the configuration is going to look like, and it will tell you how much it's going to cost down to the cent. So this is a really good place to go if you're looking at getting a good estimate for the costs. Okay, yeah, if we don't have any questions, yeah, thanks everyone for your time. And if anything else comes up, please just send us a note and we'll see if we can answer your question. Can you import? There's a question here. Can you import load tests into Azure Load Testing? Do I have to use JMeter? Yeah, so Azure Load Testing, you need a JMeter test. There are, if you've got a JMeter test already, then you can import that into Azure Load Testing. So when you're setting up your Azure Load Testing application, your Azure Load Testing environment, you can upload an existing JMeter script. If you've got a load test written in another tool, it depends. There are some places you can convert things into JMeter. It depends what it is. Yeah, it depends on what environment it was written in. If it's in JMeter, you can just upload the JMX file into Azure Load Testing and you can import it directly. You might want to parameterize the host name that you're testing, like I showed you in the demo, instead of hard coding it in the JMeter file. But otherwise, yeah.
I think we good. Final call for everyone to ask the questions. Else we call for a wrap. So yes, I think we good, Anthony. Thank you so much, Anthony and Nikita. Thank you everyone for joining us today. Please go through the link. It will take your learning further. And please, as Nikita has asked for the feedback and uh, a question, like you all can drop your questions to this link for Azure Load Testing. It's AKMS bar Malta feedback. Yeah, you can post your questions there. And I think there is one question from Bhupesh. Is there a way to find a utilization of Cube server?
Mhm. Yeah, that would be the if you want to see. So once you've got AKS running in the portal, you can go directly to Insights, and you can look at the utilization of any of the components. If you want to see that in the Azure Load Testing environment, you would do the thing I showed, which is to add a component first. So you would set AKS as the component, and then the second thing you would do is configure the metrics. The specific metrics are in the demo link. So there is a list of the metrics that we think would be useful for most people, which is the node CPU percentage. So that's basically the CPU percentage of the servers that are actually running in the node pool. But if you want to look at that in a particular namespace, you can do that as well by just changing the specific metrics. There's actually hundreds of metrics you can pick from. So yeah, you might have specific needs. But if you look in the demo repository and scroll down, there's a whole section on metrics in there.
Thank you, everyone. Thank you for joining us today.